Okay, we're just looking at a short topic on surface area of prisms. Following topic might be the volume of prisms. So the basic prisms that we're looking at are the cube, the rectangular prism, the cylinder, and the triangular prism. And there's a couple of other shapes we'll look at right at the end of the video. So take notes if you need to. Okay, so we're looking at a cube. A cube has a face that is a square here, and each of the faces is a square. And so the area of a square is length squared, and there are 6 of them, so the surface area of a cube is 6 length squared. With a cuboid, the rectangular prism, you've got lots of rectangles, but there are pairs of rectangles. So each rectangle has a pair, so I'll just highlight different colours. So each of those rectangles has 2 on opposite sides, and so each rectangle is length times width for a rectangle, but you might have, for instance, length times width for one rectangle, length times height, and then width times height for each of the different rectangles. So they pair up, and there are 2 of them because there's a top and a bottom and a side and things like that. So the formula is 2LW plus LH plus WH, and we'll get an example of that in subsequent slides. Okay, the cylinder. Okay, so we've got, again, two basic shapes. We've got a circle at the top and a circle at the bottom, and so each circle is going to be pi r squared, and we have 2 of them, so we have 2 pi r squared. And this curved bit around the outside, when you open it up, becomes a rectangle, and the top is the width of the rectangle, which is the circumference, so 2 pi r, and multiplying by the height to make a rectangle, so we end up with 2 pi r squared plus 2 pi rh, which can be factorised to that formula, and that's a useful way to look at it. The next one's a harder one, and that's the triangular prism. But basically, again, we've got some basic shapes. So we've got a triangle at the front and a triangle at the back. And each of the triangles is, so a triangle is base times height over 2. But because we have 2 of them, because there's one at the back, the 2's just cross out. So we end up just with height times base, which is the triangles. And then all the other faces around the triangle are rectangles, and each rectangle is just length times width. So we end up with length times side 1 plus side 2 plus side 3, and side 3 is normally the base. And we might have to use Pythagoras to find some sides. So copy that, and we'll do an example in a few minutes. Okay, so we're looking at some examples. I'll just work these through with you. Okay, so we've got a cube because we've got the sides, so surface area equals 6 times length squared, 6 times 4 squared, 6 times 16, and so the answer is 96. The units are metres, so we say metres squared because we're measuring area. Now, in the textbook, they might say TSA, total surface area, so it doesn't really matter which one you do. The next one is a rectangular prism. I didn't draw the right angles in, but it's a rectangular prism. So what we need to do is we just need to pair the numbers up and double them. So we have 2 times 5 times 2 is 10, 5 times 3 is 15, and 2 times 3 equals 6. So it doesn't matter which order you pair them up, as long as you pair them up. So then we've got 25, so we've got 31 there. So it's just 62. The unit is metres, so we say metres squared. Okay, so copy that and come across. Okay, so we're looking at a cylinder, and again, TSA equals, I'm going to use the short version, 2 pi r plus h. Now that number there goes all the way across, so we need to halve it. So it's 2 times pi times 3 times open bracket, radius is 3 and the height is 10. So we've got 2 times 3 is 6 pi times 13. So the answer is 6 13s are 78. So that's the answer exactly, but obviously you use on a calculator most of the time 3.14 or the exact pi. So I'll just do 78 times pi on my calculator. And so that answer is the exact answer. And the answer as a decimal is 245.04 metres squared. So that answer is exact, and that answer is 2 decimal places. So it just depends on what the question's asking for. Okay, so let's move on. Next one is a triangular prism. So this distance here is the missing distance, and it's opposite the right angle, so it's the hypotenuse. So we need to find it because we need to find that the area of that rectangle. So we use Pythagoras. So we've got 6 squared plus 8 squared, 36 plus 64 equals 100. So h equals the square root of 100. So the height is 10. So that side is 10. Okay, so now we can just do the total surface area. So the total surface area is height times base plus length times side 1, side 2, and side 3. So it's just 8 times 6 plus the length is 5 times 8 plus 6 plus 10, side 1, side 2, side 3. So we get 48 times 5, 16, 24. So 48 plus 120. So we end up with 168 meters squared. So just remember, sometimes you're given that number and you have to find that. Another one that's possible is a triangle like that, and you might have to, so if that's the base along the bottom, you might have to drop a line down to make the height, and then you have to halve the base. So if that was 6 all the way across, then that would be 3. And if you're given that number, like that's a 5, then you can use hypotenuse, that's how Pythagoras is to find the height. Okay? So just remember, if it's given like that, you need to think about Pythagoras again. Okay, copy that and come across. Okay, so the only other types of shapes, again, that you can get is composite shapes. So you've just got to look at, what shapes are there, what shapes are present, and then look at what faces are hidden. So what I mean by that, for instance, is like that face there. So you've got a rectangular prism 1 and a rectangular prism 2, but that orange face there is hidden. So you'd have to find, like that face there is the same as that face there. So just have to move it in if you like. So we've got, TSA equals cuboid 1 plus cuboid 2, and then you've got to say minus 2 times the hidden. It just depends on if you get any questions like this in the book. So the reason we subtract it twice is because it's hidden on the first one and it's also hidden on the second one. Shape like this, again, just depends. You've got a circle, you've got an outside curved bit, but then you've also got an inside curved bit. So, like for instance, the surface area formula, you've just got to remember that that part is the curved part around the outside, and then these are your circles. So for instance, that one there, that shape there is 2 circles cut out, so that's going to be circle 1 minus circle 2 to find that area. But then these curved bits inside and outside are going to be 2 calculations of 2 pi r h. Again, it just depends. Here we've got a cuboid, and here we've got half a cylinder. So you just got to use the formulas and then think about, are there any hidden shapes? Okay. So you may not get any of those in the worksheet to start with, but we can look at those at a later date. Okay, moving on. We've got a couple more to go. Okay, so another one that comes up in the worksheet, even though this is not a prism because it doesn't have a constant shape all the way through, but it's still doable. So what we've got is, we've got a, let's change my colours. So we've got a shape on the bottom, which could be a rectangle or could be a square, but whatever the bottom shape is, that's just length times width. So it's base 1 times base 2, and they can be the same numbers, or they don't have to be. And then the other thing is, we've got triangles all the way around, and if the triangles aren't the same, then you've just got to use the triangle formula, height times base over 2. Whatever the heights are, they could be the same if it's a square base, or they could be different if it's a rectangle base, and we'll look at an example in a sec. So we end up with base 1 times base 2, which gives me the bottom shape, and then the triangles, there's 2 triangles that are the same, so that triangle there is the same as the side triangle, and the front triangle and the back triangle pair up. So we've got 2 faces that are the same, and height times base over 2 is the triangle formula. So in the end, these 2's cancel out. So you end up with this nice, neat formula. Total surface area is just base 1 times base 2, which is the bottom bit. And then this is 2 of your triangles, and this is your other 2 triangles. And if the base is a square, then these 2 are going to be the same. So you end up with 2 height bases. So copy that, and then we'll look at an example that goes with it. Okay, so here's an example. I've got a square base and I've got 1 height. I don't have to give this height because it's going to be the same number. So the total surface area will just be 6 times. So I'll just copy the formula down again. So it's just going to be base squared plus 2 height base. So it's just going to be 6 squared plus 2 times 5. That's the height times 6. So 36 plus 60. So that's 96 meters squared. Okay, so there's some straightforward ones like that. Again, Pythagoras might come into play if you need to find the height, but I don't think so in the first ones. And the last one I want to do is just this last one, which is a trapezium. So I think they're called trapezoidal prisms, but that face there is the trapezium because it's got 2 parallel sides. And the formula for the trapezium is height on 2, I'll just change that to pen, height on 2, where that number there is the height between the perpendicular sides, and these are your 2 parallel sides. So that side is 4, that side is 7, and they're the parallel sides. And so the formula is, you've just got 2 trapeziums, a trapezium at the front and a trapezium in the back, and then you have 4 rectangles, and you have to be given enough information to find each of the rectangles. So in this particular one, I'll change colours because yellow is a bit bright. I'll change it to black. So TSA, okay, so we've got height over 2, okay, multiplied by 4 plus 7. So that's your trapezium, height on 2, and then we double it because there are 2 trapeziums, okay. So 2 over 2 is 1. And then we've got 4 rectangles. So the rectangle on the bottom is a 7 by 5. The rectangle on this side is a 3 by 5. The rectangle on the top is a 4 by 5. We need to have 4 rectangles in the end. And the last rectangle is this rectangle on this side. So that's a 4 by 5 as well. So we've got 2 over 2 cancels out, 4 plus 7 is 11, so we end up with 22, which is the trapeziums, and then 35, 15, I'm just multiplying the numbers. Okay, so 22, 57, 22, 57, 57, 62, 72, 92, and that's 112, all up. Okay, so that's it. And there's a worksheet that goes with it. Okay, thanks.